a saponification reaction. That is the reaction between a fat or an ester and an alkali. So we're going to start with 2 milliliters of castor oil. That's going to be our fat or our ester. And I'm going to transfer that into a 100 milliliter beaker. To that, I'm going to add 5 mils of ethanol to help the castor oil to dissolve better, because you know oil and water don't mix, and the alkaline solution I'm going to be adding later on is essentially water. So this ethanol is going to help the castor oil to dissolve. Now I'm going to very carefully measure out 10 milliliters of sodium hydroxide solution. This is highly concentrated. It's 5 moles per decimeter cubed, 5 molar solution. We're using sodium hydroxide because soaps are the sodium salts formed when long-chain fatty acids found in fats and oils react with sodium hydroxide according to this word equation. This is what's known as a hydrolysis reaction, which means breaking down the triglyceride molecules, the ester molecules in the fat, using water, because the alkaline solution is mostly water. We're now going to speed up the reaction by standing the beaker containing the ethanol, sodium hydroxide and castor oil in water, hot water, and stirring. While we're stirring the mixture of oil and alkali, the fat molecules in the castor oil are being hydrolyzed, which means broken down, to make free fatty acids. These free fatty acids are then going to combine with the alkali to make an impure soap, which we can filter off later. This process is called the alkaline hydrolysis of esters. So once we've stirred the mixture inside the beaker of hot water for 5 minutes, we're going to need to precipitate out the soap, because at the moment it's just a suspension inside the mixture. To do this, we're going to need sodium chloride or common salt. I've got a saturated solution of sodium chloride here, and I'm going to measure out 10 centimeters cubed, 10 milliliters of it, and then I'm going to add it to our soap suspension in the 100 milliliter beaker, and again I'm going to stir. After this, we're going to need to cool the mixture in iced water. This is going to help the soap to precipitate out. The longer we can possibly leave it, the greater the yield of soap is going to be. I'm going to leave my mixture on ice for about 15 minutes, stirring occasionally every couple of minutes or so. One way of helping yourself to remember that saponification is all about the manufacture of soap is to remember that the word sapo is the Latin word for soap. You can also remind yourself about the ingredients used in the soap manufacture process by thinking about the history of early soaps. We think they were made as early as 5,000 years ago, when the ancient Babylonians boiled animal fats with ashes which contain potassium hydroxide. So that's fats with an alkali. The last thing we need to do is filter off the soap that we've precipitated out using the sodium chloride. So I've just set up a standard filter funnel filter paper arrangement. I'm going to scrape the mixture into it and wait until the filtrate has finished dripping through. And here's the final product. To test it, all we need to do is take a very small amount of distilled water and put a spatula full of our soap in it and shake it to see if it forms a lather. And it does, so we've successfully made soap, but it's important to note that I'm not going to wash with this. It still has very hazardous alkali in it. To recap, saponification means making soap from a fat or oil and sodium hydroxide via a hydrolysis reaction.